Okay, welcome back. So now let's switch tool from the Snappy. Let's compare Snappy to Fluent Meshing to see which one is better or which one is more flexible or if we get something similar. So same workflow, all the geometry, everything generated in onshape, but in onshape I export everything as a step file or a good cat exchange tool, and I have it here already in spaceClaim. So the external domain here, I make it bigger, okay? So it doesn't matter. So basically I have, let me call it here domain. So let me save it here, domain. And then the void meaning body of influence. So around inside this body or outside, depending on what I want to do, I want to have something finer. Okay. Then recall that here you go into groups tab, and in this tab, you can do the selection of inlet, so for boundary conditions. And any tool that you use, commercial, open source, this is a step that you must do. Otherwise, you cannot assign boundary conditions. So have the Ahmed, I did the same subdivision, support, okay, Ahmed there. And then also I select here a few edges, okay, so I can apply also edge refinement. So you just click in the edge and you can select it. Remember that also you can go here and you can hide now the surfaces and so on. So this one I misspelled there, should be support. Then here also you can hide it and you have that single body. So it's up to you, okay? So for our purposes, let's show everything safe. And this will be my geometry, okay? This is what I will use in Fluent Meshing to create, and I will try to reproduce something as close as possible now to what we did in Snap. Okay, so this case, I read it here. I have the mesh tool open and yep, I'm ready to go. A reminder, I'm using the student version that you can download. In the video description, you will find the link. So it have restrictions, but for these cases that we are using restrictions in terms of the mesh size. But I think for 3D mesh, if I will recall, is 1 million cells. So if you get something more than 1 million, it's going to tell you no, you cannot do it. Okay, so here we go, watertight, import geometry, meters, let's select. To point out here also you have options. Things can be a little bit tricky, but similar to what we do, recall in a Snappy that is that you can do a separate by zones and you can give an angle regions. You can do something similar here. So it's not only limited to Snappy that normal tools do that, but usually you have the cat, you have all that subdivision. So that would be something that you will do if you have dirty geometries. You can have multiple files. So okay, and actually also you can read meshes. So let's get the Ahmed here. Okay, we have the geometry. It takes some time because it's converting, identifying all the patches and so on. So here, let's work with local sizes. So see that, recall that in our geometry, we have a few, recall that Ahmed void. Okay, this is the body of influence, and this will be body of influence. And the size here, look at that, you can define. And if I will recall, it will be 0.1. Okay, so because if we go back, and actually I don't recall here, my background, my block mesh, so let's reproduce, is 0.1 actually, 0.1. Okay, so and the refinement level, no, that was 4. Let's try for this one because it 2. So yeah, if I use 4, I will be out of that 1 million. So let's use this values 1.1, so twice those, because to avoid the problem, the license. So there you go. I add that local sizing. You can add some other sizing. For the moment, I will leave it like that. And see here that I go 0.2, so I'm doing that half. Now the cells there. Like here, I can reduce my minimum cell will be this one. Doesn't mean that it will reach it, but and you can put it even smaller. So curvature refinement, let's put 12. And as you also see that you have advanced options, so you can click there, they help see what is happening. So we're okay there. So let's generate the first step. It is the surface mesh, and let's see what we got here. Okay, we have a mesh. Let's see what we have. Select, let me select, no, I can't select that face. Why not? Okay, let me select that plane, flip, there. So this is what we have. Nice. Okay, beautiful growth rate. Recall that in Snappy, this will be 2 to 1 horrible growth rate here. So using full instructors, you can control that very well. So everything perfect, no complaints, except that the on the surface probably is too coarse. So let's add another refinement there to control that. So you can go back there, date. Okay, yes. And let's add a new refinement. So basically, let me select there and there. And let's say 0.5, maybe. I don't know. So let's see how. So yeah, no, it's too small. Oh. Now here I'm thinking about now the maximum memory that or maximum number of cells that I can use. Now that will be too large. So let me use this one, because I think now when I generate the boundary layer, product will get non-orthogonality problems, and then I will show you that as you refine there, you solve the problem, similar to a snappyHexMesh. So the same problems that you have there, you will have it here. Okay, so probably here it's easier to control. There you go. On generate, and we should have a mesh very soon. Okay, there you go. Our mesh, much better. Quite nice mesh, I'd really like. So super easy, super fast. The most important, the workflow, very similar to Snappy. The most important is that now you have a freaking GUI that can make sense very easy. Okay. And there you go. Yeah, fantastic. Here, select here, describe, move, boom. And let me go here. I make wall. Okay, I don't care there. Let me use this. This is okay. And then add boundary layers. So let's say that I want to add in labels, and I want to add it just to keep things simple. I want to add it in this tree, in the Ahmed boundary. I'm not going to add it in the ground, but it will be the same. And you can add different boundary layers now. So here you can select this one, you can put 3 there, then you can select another and put 10. So like we do in a Snappy, okay? And here, let me put transition, let me put 8, okay? So this will be something equivalent to the same that we use in Snappy, that is the relative last layer, okay? Something equivalent. And there you go. So here, let me use, so I'm not going to use my religion. I will use this X core heresy. Okay, I don't like that, but okay, let me go, click, and let's see what we got. Yeah. That was super fast. So here you start to see quality. It's really good. It's all count perfect. And well, you have your data structure similar as in Snappy, probably, yeah, even better. Then the transition, look at that, the boundaries, it will fill in everything with triangles. So if you want to use poly, my religion, let me go here, revert. So, oops, poly export. So instead of putting tetra, we'll put poly, which in my opinion are way much better and pleasing to the eye. So there you go. So the surfaces grow that one, and then you have your standard now here, X core, and that the surface here of the body, quite nice. No complaints, perfect. Everything perfect, good quality. So let me go back here and now revert and this point, let me go and use this method, last ratio, and let me put here 15. So now I'm putting a low value first layer. So here, clearly you can see that we might have a problem with aspect ratio. Let's see if we get it. So let me update there. Likely we're going to get that problem. And off we go. Okay, we have a solution. I'm perfect. Okay, no complaints. So I'm quite surprised. No problems, no errors. So, wow. So this is what is super difficult to get in a Snappy. So let's do something. Let me go even, let me add here another refinement level. So 0, 0, 0, 2. Let me go just in case 18, update and generate mesh. So these are the big advantages of using commercial tools. But they're almost foolproof. From time to time they break, but almost foolproof. Okay, there you go. This is what I was looking for to get that error. So the mesh is okay. What it's showing you, whereas you have likely high aspect ratio, high no orthogonality. So see that here it's showing me no orthogonality, but also I know that the problem issue is also related to the aspect ratio, which which is a little, which might be a little bit high. But in any case, let's visualize something there. Okay, I don't see my layer display face X. So what I want to see also here is it that may move it a little bit. Here we are in the intersection. Look at that, contrary to OpenFOAM that since collapse. This tool, this specific meshing controls very well this transition. Okay, when you have those right angles there. And I have to say that is the most difficult thing to control in Snappy when it comes to boundary layer. There are a few options now. We're going to visit that in another case, but not always work. Or actually, it works simple geometries. Then when you have very complicated geometries, it's difficult to control. And one of the issues that you have in snappyHexMesh is that many times those options are global, they are not local. And already mentioned that I have my own version that I modify, and I have a few of these options that are local. So I can control and say this surface will use this value like this surface feature. Now that, let me go here, as you open this value, for instance, let's see, this value is a global value, so all surfaces, everything will see the same. So it might be the case that sometimes you want to have different values, so I modify a version and I added no, to get two different values in this one. And also I get two different values when it comes to meshing. There is one that also boundary layer mentioned that it can have influence. Actually, there are two. This one I can have two, and the other one that I can have two is this one. Okay, so I can have two, but okay, that's no, I was with a hammer modifying snappyHexMesh, so should be something that if I have 10 surfaces, I should be able to put 10. So I just did it for two, but in any case, just testing a concept, it worked. But yeah, just to mention that. So yeah, perfect. So here you can see clearly that refinement the surface will solve the problems. Now we went from something quarter finer, normal to the wall. But let me go back here and let me add more refinement just to be sure that that will solve that problem that we have there. So if I halve this, I think it should work because also we halve the other, or we double the other. So this one should fix that problem. Okay, there you go. And as you can see, much finer. By the way, as you get here, sometimes that surface mesh can get problem, can get some issues. You right click and then here you can improve surface mesh. So you have that options. And done. This is okay. And off we go here. And it's saying here, right click, and you can add improve volume mesh. And actually all this stuff, always right click and will give you some extra options. So here is getting there. So we're going quite fast. It's to be slower or probably not running many processes. So that's why I see it very fast. So we're almost there. And there you go. We have this. We have less cells, less no low quality cell, but still we have some problems. So let's go and add another refinement rate. So let's see when I will solve the problem or get the issue with the license. That will tell me. So let me go here and let me go 0.5. Okay, that is quite fine. So yeah, I already know that. Yeah. So it should improve a lot. The surface meshing should will be a little bit slower. Okay, there you go. Let's see what we have there. Okay, this is much nicer. Okay, probably also, by the way, you see that the surface mesh is not that slow, but well, when you have complicated industrial geometries, it can be time consuming. And let's go here. Okay, so we have solutions. So we have a couple of bad quality cells. You'll see that you mark those cells there, but in general, you can see by refining the mesh, you solve the other issues, aspect ratio and so on. So you can get the idea similar to Snappy. Let me add here improve mesh before doing so, because in my experience, sometimes it will crash there. Okay, so here is giving me the problems with the license. Actually, yeah, I reached the limit. Okay, so probably that error was due to that. But there you go. So okay, so let me go with this. Let me reduce this to, we're almost in that limit. So probably if I put here 12. Okay, we have a mesh, and yeah, we were in the limit of the cell count. So yeah, nothing that I can do there. I need to reduce, but just to mention also in the boundary layer, when you have word resolving, you can add half of the cells of your domain easily can be contained there. So it's very time consuming. Let me see if it improve. Okay, it didn't give me any problem. So let's run the improve volume mesh to see if that improve. Then, okay, yeah, the licensing issues that I exceeded the limit. So, okay, I think this is it. We cover everything here. We compare. So I hope now you have another vision on different tools, how they work, the similarities. So at this point, we're done with Fluent. No, mention the tool. Then remember you can export it in ASCII format and so on. So at this point, let's move to another tutorial. I'm quite sure that I will prepare more videos for the Ahmed, but for the moment, I prefer to move to another case. So see you next time. Bye.